Okay, our goal is to prove that the angles in any triangle add up to 180 degrees. So this should be a familiar diagram. Think about ABC as any triangle. It could be isosceles, it could be a right triangle, it could be scalene, obtuse, it could be any triangle. We're just positioning the triangle so that we consider BC the base, and we want to construct a line. I'm calling it ZQ through A that's parallel to the base. And you should have seen a video that shows you exactly how to do this. So basically, it's always possible. Take any triangle, ABC, and make BC the base and construct a line parallel to BC. Call it ZQ. Now we're going to try to think about this differently. So let's forget about side AB. Now that we have just temporarily gotten rid of side AB, now it looks just like two parallel lines with a transversal. And we all know that when we have parallel lines with a transversal, we'll have congruent alternate interior angles. I could name them with the points I have here. I could say angle ZAC is congruent to angle ACB. But I could also just give these angles names so that it would be easy to see this, easy to refer to them. So we're going to call angle ZAC angle 1, and we're going to call angle ACB angle 2. And then we're going to, instead of using tick marks, we're going to use color to show that angle 1 and angle 2 are congruent because they're alternate interior angles. Okay, now remember, this used to be part of a triangle. We took side AB away so we could focus in on the transversal and the alternate interior angles. But now we're going to put AB back because now it's going to take its turn to be a transversal. We're going to cover up angles 1 and 2 so we can just focus on two parallel lines with AB as a transversal. Okay, so we covered that up just so it would look more familiar. Two parallel lines, AB is the transversal, and again we're going to have congruent alternate interior angles. So we could say that angle QAB is congruent to angle ABC, but we're going to number and color these angles also, so they're easy to see and talk about. Angle QAB is going to be called angle 3, and angle ABC will be angle 4. And they will also get a color to show that they are congruent. So 3 and 4 are pink because they're congruent to each other, and they're not green, they're not congruent to the angles on the other side. So now we're going to go back and look at our triangle, and we're going to look at our congruent angles. So we have angle 1 congruent to angle 2, and angle 3 congruent to angle 4, and we just have to name and look at the angle CAB, the vertex angle of this triangle. Now we've just named the angle at the vertex, angle A. We're calling it angle 5, and we have the congruent angles. 1 is congruent to 2, 3 is congruent to 4. Now we're just going to look at angles 1, 5, and 3, sitting there together on line ZQ. Now, these are not a linear pair. There are 3 angles here. It's almost like a linear pair, but it's a triple. It's 3 angles, and they add up to 180 degrees. You could think of a rotation through angle 3 to angle 5 to angle 1, and you can see by the way it's constructed that angle 1 plus angle 5 plus angle 3, we're adding their measures, is 180 degrees. So now let's put the triangle back. Well, the same thing is true of the triangle then. Because 4 is congruent to 3, it's the same color. We can make a substitution. And 2 is congruent to 1, it's the same color. It's really that green plus blue plus pink is 180. Look at the triangle. Green plus blue plus pink is 180. This is true of any triangle. So any triangle has angles that add up to 180 degrees.